So when I was asked for a brief as to what we'd talk about today, I thought, well, not as experienced as Roger is coming up at pithy titles, but I thought, okay, well, let's try and make it applicable to the world we live in today, to the operational nature of the business, and also introduce some new terms and terminology. So virtualization, as Roger said, I've been with a couple of startups in the last couple of years, and if today you're not using the terms SDN, virtualization, NFV, or network function virtualization, then you're perceived as being kind of old hat. So I always like to turn to Dilbert for inspiration, and many times, and I think this cartoon from Dilbert kind of summarizes up some of the requirements. The pointy head bosses say our servers are using too much electricity, we need to virtualize, and you can apply that to pretty much any piece of equipment in the head end today, CMTSs, edge QAMs, everything. Everything uses up electricity, power, space, and cooling. Now, obviously you can virtualize some elements you can't virtualize, so we'll cover that. So we'll talk about how we can apply software-defined networking techniques, network function virtualization, etc., to the traditional world of CMTS or CCAP. A little bit about Gainspeed. Gainspeed has been around for about 3 years, so it's a relatively mature startup. It's headquartered in Sunnyvale in the US, so a little bit different. Most of the CMTS world seems to be very East Coast US focused, so you get a new perspective by going west. As a company, we're relatively compact. There's about 65 employees. I am the sole employee in Europe, and I've been brought on board to try and introduce Gainspeed to the European marketplace and to assist in trials, technical evaluations, and business development. And we have a relatively small product portfolio that's made up of a number of elements. Ethernodes, I'll come on to that in a minute, video engine, and a controller. So I'd start off with this premise, that cable isn't ready for the IP explosion that everybody is talking about. We all know that demand is infinite. Whatever you will supply, consumers will use. And the network, hopefully this will point, we should all be fairly familiar with this concept of a network. We have a number of services that are delivered today. Analog video, although not present here in the UK, it is present on many European cable operator networks today. Digital video, again, we need to say very little about that. Video on demand, to a degree, is present, maybe not growing as much as it could be, but where the real growth is really in data. We know that data rates are exploding. We know that when I think about my first cable modem, I got my first cable modem, I'm trying to think of the year it was, but it's probably 12, 13, 14 years ago. I had 512 kilobits per second. I thought it was the best thing ever. It couldn't get any better. Transport myself to today, and today is it Back to the Future Day today? Which 15 years on from the film, we see what has turned into reality from what was predicted in the film. Today, my service at home is approaching 200 megabits per second. The latest upgrade and increase in speed has been announced by Virgin Media. I'm a Virgin subscriber. Very happy with the service. Thank you very much to all involved. We know that's growing hugely. So we have to be prepared as an industry for this network transformation. And to a large degree, the network hasn't really changed that much. The components that make up the head end, whether it's analog, digital, or CMTS, they're combined electrically in the head end, and then go through an electrical to optical conversion, going over analog lasers to the fiber node in the field. And that delivery mechanism typically hasn't changed very much since the introduction of fiber into the network. The service is then converted back in the fiber node from an optical to an electrical signal and delivered over the coax leg to the home, perhaps through directly to the homes, or perhaps through a couple of amplifier chains. Again, every network is different, but that's pretty much how the services are deployed today. The result of the explosion of capacity means that we have a massive hub footprint. We look in CMTS sites today. I don't need to tell you that the number of racks that are devoted towards CMTSs are many, rows and rows and rows of CMTSs devoted to delivering, what is typically just data-only services today. That's growing, and we have the constraint of the analog network. So how have we as an industry reacted to this? And to a large degree, it's through expansion of capacity. So the CMTSs that we first saw, the first CMTS I think I installed was a BSR 64000 many years ago on the Isle of Wight, UK's second largest operator, I believe, today. That CMTS, I think, when fully populated, had less than a gigabit per second of capacity. It was full of 1 downstream, 4 upstream cards, delivering about 800 meg of aggregate capacity. So not a huge amount. And to a large degree, all the CMTS manufacturers have gone through a process of replacing line cards, increasing density, going from 1x4s to 2x8s to 20x20. And then the MCMTS product introduction happened, and we went to much denser line cards. So 32 downstream line cards, 64 downstream line cards, and multiple outputs per RF port. And that, to a degree, has continued. The introduction of CCAP, introduced a few years ago, has sought to enhance delivery through the converged cable access platform. So as well as being a CMTS, CCAP has been designed to allow the delivery of digital video in the same platform, and depending on the operator, the manufacturer, some have an integrated video into the product, but it's been there in the specification. So the issue with this is it's still a very large footprint in the head end, and we still have the challenge of the analog network. So, with demand increasing or doubling every 12 to 18 months, the number of racks, the amount of power, space, and cooling is still increasing at a rate that I believe is totally unsustainable. If you think you've got to double not only the CMTS space but the analog combining, etc., then it's a huge footprint. So how do we challenge this, and how do we change this and increase the availability of broadband to the home? So here's where we get to the interesting bit, the virtualization. How do we virtualize this chassis? How do we take what is largely a physical unit, from all manufacturers? You get a chassis that's so big, that's full of line cards. How do we solve some of these challenges? And we've done so by virtualizing it. So taking the traditional CCAP model and centralizing the control and distributing the processing. So how do we do that? If we look at the elements that make up CCAP today, you have a control plane functionality. That's resident in all CMTSs. And that programs the devices, it allocates service flows, it creates the bandwidth going to each user. Each device typically has a router built in. So there is IP and MPLS functionality built into all CMTSs today. That has to live somewhere. Subscriber management, DHCP, etc. That resides in the chassis. Video is in the chassis, whether it's utilized or not. And of course you have the DOCSIS functionality and RF modulation, all within the chassis. So these chassis they're big, they do a lot, they provide a lot of service. So how can we challenge this by moving control and centralizing that and distributing the processing is through a technique. We're hearing a lot about distributed CMTSs, and there are proposals from Cable Labs for distributed CMTSs from of many different types and varieties. So we'll talk about what we're doing at Gainspeed here. And what we're doing is we are, in order to virtualize the CMTS, we're taking those functions that normally resided within a CMTS chassis and distributing them to components that make sense, that deliver best-in-class performance, whilst solving the challenges of power, space, cooling, etc. So we think about the control plane functionality that was resident on a line card in the CMTS. We've taken that out of the chassis. We have virtualized it and moved it into a cloud-based controller. So control plane now resides in a virtual machine, and that can reside Doesn't have to reside in the head end. That can reside in a data center or anywhere in your network. We've taken the routing functionality, the IP MPLS functionality, and we've placed that into a standard router, standard network router with no DOCSIS functionality, and we allow that then to do the IP MPLS. And in that way, you can remove the burden on the CMTS manufacturer to implement every IP standard out there, and you can actually just put in a router of choice from the Junipers, the Ciscos, Alcatel-Lucents of this world, and use best-in-class features on that and not be reliant on the CMTS manufacturer to implement a new feature or service. Video, of course, video is an important part of a solution today, and we've done so by taking that video function and placing it into what we call our video engine, which sits in the head end. And essentially what this does is it transports your existing video solution over the network to the remote fiber node or the ether node. So we've moved both the DOCSIS functionality and the RF modulation out of the chassis, from the line card in the chassis, into what we call an ether node. And that ether node replaces the traditional fiber node in the street furniture, and that delivers the signal. So a couple of things to say here. Can anyone point out what's missing? What else have I taken out of the network here? Give that man a prize. The analog transmission. So what we've done is we have moved to digital transmission. So instead of the traditional AM optic transmission network used in cable TV, we're just now using 10 gigabit links. And there are, I guess, a number of benefits to that. First of all, cost and complexity. 10 gig optic links have come down significantly in cost. You have a much better distance, much lower cost. So 10 gig optics can go, well, in a single link, 80 kilometers, but it really means because you're using 10 gig transport, there is no distance limitation from the hub to the street cabinet. So you can actually start thinking about perhaps removing facilities and pulling that back in the network. By moving the RF modulation, and here Gainspeed are proposing what we call a remote MAC-PHY solution. Some of the other manufacturers are talking about remote PHY solutions. I won't go into that in too much detail. We can cover some of that in the questions and answers. But by moving the DOCSIS functionality into the fiber node, you are effectively reducing the distance. There's no latency between a centralized CMTS and a remote PHY node. You are moving the DOCSIS functionality close to the customer, and one of the benefits of this is that you are eliminating the analog transport link and any losses that are introduced by that link. So here in the centralized model, the CMTS, there is a recommended post diplex filter MER level that's recommended by Cable Labs. That's great coming out of the port in the head end, but what actually reaches the subscriber is typically 6-7 dB lower than that. By moving the modulation point to the fiber node, you then gain 6 or 7 dB, which will become very, very useful when we start thinking about how we move to the future, how we upgrade to things like DOCSIS 3.1, and moving from 256 QAM in the downstream to perhaps 1024, 2048, or 4096 QAM in the downstream. To a large degree, DOCSIS 3.1 is not yet commercially available. You'll see it tested, you'll see it demonstrated by many manufacturers, but there is very little data to suggest how DOCSIS 3.1 will perform in the real world when perhaps we have a cascade of amplifiers behind the fiber node. So by moving the modulation into the fiber node, we gain an extra 6 or 7 dB of headroom. So by virtualizing the CMTS, we can digitize the network. We can bring the IP point all the way to the ether node. So because you have IP now to the ether node, you can deliver IP services from here, and you're not reliant on just purely DOCSIS. If you wanted to attach Metro Ethernet services to a device, because you're delivering 10 gig Ethernet to the node, you can very easily hang off things like Metro Ethernet, cell tower backhaul, any services that you might want to add EMEA network. It's got an incredibly small hub footprint, so we'll come on to the space savings in a minute. And it allows you to scale the service group to 6 gigabits per second plus. So today, the limitations on how much bandwidth you can provide to a service group are defined by the number of output port, the number of RF port or channels per RF connector. And typically today, that's gone, as I say, that's gone from 1 downstream many, many years ago to 2 downstreams. Now typically 4, 8, 16, 24, 32 downstreams per RF connector. By moving the functionality to the fiber node, we can now deliver what we call full spectrum DOCSIS. So in a typical network today, we have 118 channels. We can deliver any mix of services over those 118 channels between analog, digital, video, and DOCSIS. So if you wanted to turn on all 118 channels and deliver full spectrum DOCSIS, you could deliver 6 gigabits per second to that fiber node today. By implementing DOCSIS 3.1, that scales to 10 gigabits per second per fiber node. So now we're approaching what some people might call an endgame scenario of being able to deliver an equivalent service to fiber using traditional techniques. And by traditional techniques, we don't change any of the wiring. So the standard RF cabling from the cabinet to the home remains the same. We just get the option of much more bandwidth over that service. So what does this do to the head end? So this is a representative view of a 400 service group CCAP deployment using a representative CMTS. The picture really doesn't change if you change the vendor here, and maybe you might recognize the chassis here. But here, depending on how many CMTSs you put in a rack, here we're showing two large chassis in a rack. Some operators only put one in a rack. By moving to a virtual model, you can move away from this and move to a very small head end footprint. Because you've taken the chassis out, you've virtualized the chassis, you have removed the routing functionality and put into a typical router in the head end. And in our case, we're using a router in our implementations that's 3 rack units. Router provides 80 gigabits per second of capacity. Again, you can scale that independently because you've virtualized and separated data plane from control plane. You can scale the data plane accordingly. So if you want to go from an 80 gig router to a 240 gig router or a 960 gig router, then that's something that you can very easily do by only increasing a few rack units. The video engine sits in the rack, and last of all, you have a very small switch footprint. So we move from a world of very large scale deployments to a very, very small hub footprint. And as we know, power, space, and cooling is probably a greater challenge to operators today than how to scale data services. So every operator is different, but I would say that there is at least a 12 times reduction in rack space required by virtualizing and distributing the components. There is a huge saving in terms of power in the head end. There is some more power required in the fiber cabinet, and we'll come to that. There's a huge increase in capacity in the fiber efficiency, because you can move to 10 gig optics, you can run multiple wavelengths, you can get a huge amount of capacity out of a single fiber. And there are no limits in distance from the hub to the node. So in kind of summary, the value in virtualization means that you can really optimize the real estate in the head end. Massive reduction. We showed this last week, I think, at SCTE. We actually had a traditional operator's view versus a Gainspeed view, and it got a huge amount of interest. By moving the IP domain to the street cabinet, to the Ether node, you can now increase revenue, as I said, by delivering new services. So whether it's DOCSIS services to the home, whether it's because it's 10 gig to the fiber node, you could put upon an OLT device in the node and deliver PON services again. You could deliver cell tower backhaul, for example, a very popular theme at the moment. Delivers you a stepping stone towards fibre to the home. There are always times when HFC may not deliver enough capacity. Because you have 10 gig optics, because you have dark fibre going to the fibre node, you can deliver multiple services from there. You can reduce your operating costs as well. You have, because you're digitizing the device, you are removing the analog optic link. You are removing the need to calibrate that link sometimes several times a year. You're just using 10 gig optics, which are hugely reliable and much lower cost. You have massive savings in power in the head end. So in kind of summary, you have a much lower total cost of ownership by virtualizing the CCAP world. You can seamlessly scale service speeds, so you can go today, typically today your limits, as I say, are the CMTS capacity per port. We've solved that by delivering full spectrum DOCSIS. You can deliver services that are scaled according to the available CPE. So today, 24x8 modems are now becoming commercially available, but starting to be deployed, and that allows operators to move to a gigabit service to the home. Today, a 24-channel DOCSIS modem can deliver 1.2 gigabits per second of capacity. Now, it's only got a single gig port on the back of it, so there's a challenge there, and perhaps we'll see a new generation of devices in the home that have 10 gig outputs or multiple 1 gig ports. You've extended your Ethernet access network right the way out to the field, so now you can deliver new services, and it allows you to rely on shall we say, industry standard protocols and techniques over Ethernet, rather than perhaps on proprietary implementations such as DEPI, UEPI, and new timing protocols that are required with that. And really accelerate the transition of IP delivery of services for all, so for video, for data, etc. So that was shorter than I thought it was going to be, but I thought I'd leave a lot of time for questions because I'm sure there are many questions. Thank you.